Okay, so I want to run through and go over these density worksheet questions really quick. We have an introduction to the density pyramid here. Basically what this is saying is that anything we're trying to find, if we cover it up, we can have the equation to find that variable that's missing. Usually they give us two of the variables, say density and volume, and then we have to find mass. So the way this works is since density and volume are next to each other, that's like a multiplication. And then with mass being on top, that makes a division with density and volume. So for example, if I was trying to solve for density, then I would cover up density, and I'm left with mass over volume. So I would do mass divided by volume would equal density. If I was trying to solve for volume, I would cover that up, and I'm left with mass divided by density equals volume. If I'm trying to solve for mass, cover up mass, and I'm left with density times volume, so density times volume equals the mass. And so that's how we find the missing variable. And that's pretty much what these problems are all about on this worksheet. So let's go ahead and run through them quickly. So, all right, we have a gold colored ring. They're telling me the mass. It's also important that we pay attention. We know our units. We should know that grams, anytime I see that, that means mass. Anytime I see milliliters, that would be volume. Another one that's volume, of course, is cubic centimeters if we see that. And then if we see grams per milliliter or grams per cubic centimeter, of course, with those we are talking about density, okay? So that's important to note so that we know just by looking at data, we know what they're giving us. So at number one, they're giving me the mass, they're giving me the volume, and they want us to find the density, because ultimately with density, as it says in the above paragraph, it's a characteristic property, meaning that a certain substance is always going to have the same density under certain conditions, as long as the conditions are the same. There are conditions like pressure and temperature that can affect that, but if we're just talking about a standard temperature and pressure, it would always have the same density. So if I went back to my density triangle, all right, density pyramid, whatever you want to call it. I'm trying to solve for density, so I'd cross this out. I'm left with mass over volume. So 18.9 grams divided by 1.12 milliliters. So it's just a division problem. So I'm going to go 18.9 and divide by 1.12, and I get 16.9. And that's grams over milliliters. All right, so that's my answer. If I compare that to the density of gold, then I can see that the density is not the same as gold. Therefore, I would say it's probably not gold. Not, at least not pure gold. All right. All right, and number two, get some of this out of the way here. So they're saying, what volume? We want to find the volume. All right, so this time we're going to do mass over density. They're telling me grams. We know that that's mass. And they're telling me the density is 1.29 grams per liter, okay? Per liter this time. By the way, that's a different unit. Usually we're dealing with milliliters. Talking about gases, a lot of times we'll use liters. So my answer for this, for volume, will actually come out in liters. But I'm going to do just like the pyramid says to do. I'm going to take the mass, 0.871 grams, and I'm going to divide that by 1.29. And so if I do that, wish I could get this thing to move away. Move. If I do that, I'm going to get 0.871 couple sneezes, divided by 1.29, and I'm going to get 0.68675. And again, that unit, grams over liters, we're actually going to have a volume of liters. So that's your answer to number 2. All right. So clean some of this up. All right, moving on. Number 3. Pumice is a volcanic rock that contains many trapped air bubbles, a 225 gram, okay, so that's mass. Occupied milliliters, that's volume, all right. So I've got mass and volume, that means they want me to find density. Okay, so find density means mass divided by volume. So 225 grams divided by 236.6 milliliters equals 0.951 grams per milliliter. It's also important, so we're learning about comparing densities to determine if something will float or sink in water. So when we're comparing those densities, make sure that we have the same units that we're comparing. But generally, if the density is less than something else, it's going to float. If it's more dense than the liquid you're putting it in or the gas, it's going to sink to the bottom. So in this case, with pumice being less than 1, that means it's going to float. All right. Number 4, a cup of sugar has a volume. Okay, there's volume. What is the mass? If the density is this. So this again, this time they want us to know what is the mass. All right, so cover up the mass. That means density times volume or volume times density, same thing. So 237 milliliters times 1.59 grams per milliliter. And let's see what that equals. So 237, oops. 237 times 1.59, and I'm going to get 377. Okay, and that is mass. That will be grams. There's your answer. Okay. Make a model that compares the particles. So we know the density of pumice here. It's 0.951 grams per milliliter. And sugar, we just found out, is 1.59 grams per milliliter. So if something is more dense, the particles are going to be close together. If something is less dense, the particles are going to be more spread out. So since the pumice is less dense, I might draw those particles kind of spread out in it. Whereas with sugar, I'm going to draw particles that are really close together. So maybe I have to draw more particles if I have the same size box and same size dots. Something like that would work. Okay? It's just important that we can make models that show different densities, identify models that have different densities. That is our success criteria, our main success criteria for this portion of the unit is working with models to understand density. So number 6, which has a greater mass? 1 liter of water, 1 liter of gasoline. If you're curious, 1 liter is 1,000 milliliters. Okay? But basically, they're saying that they have the same volume. Okay? They have the same volume. And so I don't even need to worry about the 1 liter. If I just look at the density, I know what this means, and these are for every statements. And these are important, is I know the density means for water, for example, for every 1 milliliter, there are, this is the standard format, for every, there are 1.00 grams. Okay, that's for H2O. Now, for gas, if I do that same for every statement, for every 1 milliliter, okay, that's a density, there are 0.68 grams, and that's the gasoline, okay? So just by looking at that, if I had just 1 milliliter of each, the mass of the H2O is going to be more. Same thing if I had 100 milliliters or 1,000 milliliters, okay? It's still going to be H2O has more mass. All right, number 7, a crumpet recipe calls for 175 grams of flour. They're telling me mass. According to Julia Child's data, the density. They're telling me mass, they're telling me density. They probably want me to find volume. And sure enough, how many milliliters? That's the volume. So mass. All right, we want to find volume, so I'm going to take the mass and divide by the density. 175 grams divided by 0.620 grams per milliliter. So milliliters is the volume units we're dealing with here. So my answer is going to be in milliliters. And so 175 divided by 0.62. And that comes out to be 282. We'll go at 280. We'll say 282. 282 milliliters. So now we know the volume. All right. Okay, from their density values, decide whether each of the following substances will sink or float when placed in seawater, which has a density of 1.025 grams per milliliter. So, seawater, a little bit higher density than regular water, but all I got to do is compare these densities to it. If it's less, it's going to float. If it's more, it's going to sink. So gas being less is going to float. Mercury being more is going to sink. Asphalt being more than 1.025 is going to sink. And cork being less is going to float. That seems to make sense to me. All right. And number 9 is a biggie. You are going to see this on a quiz or your test on Friday for sure, because this is really understanding a lot of different things. Us chemistry teachers really like this question. Use the following densities. So what you want to do is if you're going to combine them together, there's going to be a column, all right? We'll say. It could be a beaker, it could be a graduated cylinder, it could be whatever. But these are going to make 4 different layers. So I'll put one here, one here, one here. There's 3 layers, there's 4 layers, okay? So the most dense, being mercury, that's going to be at the bottom. So I just want to label this bottom layer mercury. I should use different colored dots for these two, being different substances. Maybe I'll make, I should have made blood red, but oh well. All right, so blood would come next because that has the next highest. And then we'll have water because that's the next highest. And then we'll have ethanol because that has the least density. All right. So the most dense, I'm going to put the particles closest together. Maybe do something like that. And then I'm going to do a little more spaced out for these guys. Actually, that's a pretty big difference. I should do them a lot spaced out, but it's the idea, it's the concept. It's fine. Water, a little more spaced out. And then the ethanol, even more spaced out. That shows that you understand that the spacing is farther apart if it's less dense. It also shows that you understand that more dense things will go to the bottom, less dense will go to the top. That's how you do that problem. All right, and then number 10, mercury is a liquid metal having a density of 13.6 grams per milliliter. What's the volume of 1 pound? We don't really deal with pounds. We do deal with grams, though, 454 grams. What is the volume they're asking for? All right, so there's my pyramid. Finding volume, so mass over density. The mass is 454 grams. It is important what you put on top and what you put on bottom, by the way. You get totally different answers. Grams per milliliter, so I'm going to get an answer that's in milliliters. So I get 454 divided by 13.6. And I'm going to get 33.4. And the units are mLs. All right. Number 11, a sample of lead. So this is a displacement problem. So we have, what is that, 32.6 grams. That's going to be the mass. And we have a graduated cylinder. We put 2.8 milliliters. Me personally, I would like to put it into some kind of regular number of milliliters because it's up to us how much we add. I would maybe make it like 5 so it's easy to read, exactly 5. After the lead sample is added, it goes up to 5.7. So when we started, it was only at like 2.8, but then when we put the object in, it goes up to 5.7. So this difference in volume is due to the object that we're putting in there, so this lead sample. So if it goes up to 5.7 and it was initially at 2.8, I can just subtract and find out that the volume of the lead sample, they're talking about milliliters, all right, is 2.9 milliliters. It's just a difference. That's what made the water level go up. So now I have the volume. They want us to calculate the density, so we're finding density. So in our triangle here, we're calculating density, so we just need to make sure we have the mass, which we do. It's 32.6. So I'm going to go 32.6 grams over the volume of the object, which we found by displacement is 2.9 milliliters. And it's just a basic math problem now. So we're going to go 32.6 divided by 2.9, and we get 11.2. Or really, I could say with these sig figs, I could say 11. And my units are grams over milliliters. And there's your answer. And we're good on that. And number 12, I told you you could skip that because we're not dealing with volumes of cylinders. So those are all the answers to your density worksheet.